Good morning. Here's your walkthrough for 10-5. I'm going to get you started, so I'm not going to give you the answers for the work, but I'll get you the steps to get you there. So we're going to start with, I've got 1 through 5 drawn out on my white contact paper here, but 6 and 7 are extensions. So 6 is the short answer. You're actually going to write down the theorem. There are 2 theorems that you're going to be writing down. That's what they're looking for you to. So basically you're reiterating what the 2 theorems are. And then in your diagram with the ice cream cone, they're asking you to give the percentage of the circumference that is on the inside. And all you have to do for the percentage of the circumference is write the fraction. What's the fractional part of that circumference? So once you have a fraction, you can easily make that into a decimal and then into a percent. So right there, you're looking to write a fraction and convert that to your decimal and percent. All right, so we're going to start with number 1. Number 1, you have the secants intersecting on the inside, so we have interior angles formed. Interior angles are going to be half the sum of the 2 intercepted arcs. So they gave us 2 intercepted arcs that measure 30 and 94. So I'm going to add those 2 together. First thing is identify what they are, and then the formula or the theorem that's being used. And then we'll get to how we find BEC, which is over here. This is the thing we're looking at. So to find that, there are 2 ways to do the problem. First way, I'm going to show you I'm going to get you started on what we're given, not what we're not given. Okay, 30 and 94. So I know that the angle is half the sum of the arcs, which is going to be 124 degrees. So half of 124 degrees is 62. Right. Now I'm checking, and I know remember I don't draw a 2 scale, so this is 62 degrees, this is 62 degrees. Okay, now how do I find BEC? Well, remember these 2 angles are a linear pair. So what does the linear pair add to? Well, when you know their sum, subtract 62 from that number, and that's the measurement of your angle. That's how you're doing number 1. Okay, number 2, we have over here, I have triangle PRQ. So here's P, R, and Q. All right, and what's different with this one, we have 2 tangent lines, so they're not secants, tangents. Tangents are different. Tangents don't have any intercepted arcs. It actually touches the circle in 2 places. And the largest degree it can intersect at is a semicircle. So anywhere from 0, greater than 0, but less than 100, or up to 180. And what we end up with is that this is going to be half the arc. Distance. So 60 degrees is going to be half the distance from P to R. That's what's nice about tangents. You don't have to, it's just like working with the inscribed angle. So we used to jokingly call them the outscribed angle. That was actually not my idea. That was a math teacher's idea, and of course we all forced to laugh. So if they're 2 tangent lines, same thing as an inscribed angle, and that's where the vertex is on the circle. It's going to be just double it, and that's your degree measure. Okay, that's number 2. Okay, we're on 3, 4, and 5. We're using segment theorems. So on 3, we have a tangent line and a secant line. And I'm going to switch the phone over to my mom. She's going to hold it for me. So here, you just have to hold like this. Okay.
I'm not getting paid for this.
I made her coffee. Don't listen to that. Okay. So what we're going to do, we always start with 1 line. And I'm going to, it's usually take the outside length and multiply by the sum of the total distance. Well, I don't have my total distance is 6, and my outside length is 6 because it's tangent. So that what I start with is 6 times 6 And that's going to be equal to the same thing down here. Outside length times total length. So that's going to be 4 times 4 plus x. All right. So 36 equals, use your distributive property, 16 plus 4x, and then use your algebra to solve for x, which means you're going to subtract 16 from both sides, giving you 20 equals 4x.
10 divided by 4.
Yep, Mom's got it. So 5 is equal to my x. And then if they want, so if they wanted that chord length, you now have it. If they want the entire length of that line, so, or the segment chord and to the point, it would be, you would have 4 plus 5, 9. Okay, next, so that's 3. So 4 is over here. We're getting now 2 secant lines. It's the same thing that we're doing. We're going to take, we start with the outside line segment, which is length of 8. Okay, total distance, so 8 plus 10, 18. This is equal to 10 times 10 plus x. Okay, 8 times 18 is 144. I did the math last night. That's why I did not just do it in my head. I'm going to distribute 10 through, so I'm going to get 100 plus 10x. Okay. Now, same thing. We're going to subtract 100 from both sides. I'm going to get 44 equals 10 times x. All right. Divide by 10. That gives us this section here. So then you're either answering the length of the chord or the entire length of the 2 segments put together. So that, all right. So the last one we're going to do is number 5. You're going to step carefully to the to your left.
Very carefully.
Yep.
All right, number 5.
Number 5. So we're given several bits of information here. So we're going to start with what we know. We know that we have the arc length from R to S is 90 degrees. I'm sorry, the arc distance is 90 degrees. And then V to U is 80 degrees. We have an inscribed angle that's 70 degrees, which means I know that this arc, I can find this arc here using our formula. Inscribed angles, we double to get arc distance. So 70 times 2 is 140. Okay. And next, we've got 1, 2, 3 arcs that we know. Here's the 4th arc. All the arcs in our circle are going to end up to 360 degrees. Yeah. So what you do is...
Add those?
Yes, you're going to add those. Can you tell me what that sum is, Mom?
It was 310. Wait a minute. Is it an 80? 80 and 90 is 170. Yeah, 310.
Okay, so the 3 arcs together are 310 degrees. What's left over to make 360?
50 degrees, ma'am.
Okay, see, look at this. All right, this is an outside exterior angle.
Yes.
So it's these aren't tangent lines, so I can't just say, oh, it's half this measurement. It's not, because it cuts the circle into 2 arcs. So I have to use a formula, and it's usually where the first thing we want to do is say, oh, it's like an inside, like number 1. I have 2 intersecting chords, and I want to add them, but not with an outside angle. With the outside angle, because you're moving further away from the circle, so you're getting a smaller angle, we're going to use subtraction. So it'll be, the formula is 140 minus 50.
90.
Okay, so I take the difference, and then I'm going to divide it in half. And
45.
And then, of course, so that gives us 45 degrees. And I believe my mom just gave you the answer, RTV. So angle RTV is, in fact, 45 degrees. All right, there you are. Thank you. Have a great day.